day, ladies and gentlemen. Good day, miss. So, I'm Princess Mayang Latera, and in this presentation, me and my group mates will discuss about GMO. GMO stands for Genetically Modified Organism. But before that, I have a question. Just two questions. First, how many colored roses have you ever seen? Second, have you ever wondered how do they attain these different kinds of colors? Now, we will discuss and we will discover what is GMO all about, and is this safe for us? Is this safe for our environment? So listen and stay put. So first, let's define GMO. GMO, genetically modified organism. Genetically modified organism is the term used for an organism created through genetic engineering. The World Health Organization, or WHO 2014, defines GMO as an organism, either plant, animals, and microorganism, in which the genetic material DNA has been altered in a way that does not occur naturally by mating or natural recombination. So the GMO is used to produce medicine, genetically modified food, and in scientific research. Also, the development of the GMO was perceived to help in the advancement of the technology for the benefits of humans in different industries like agriculture and medicine. To understand more, let's proceed to genetically modified organism in food and agricultural industries. The Center for Ecogenetics and Environmental Health identified the following roles of GMOs in the food and agricultural industries. So first, we have pest resistance. Pest resistance is genetically modified plants to resist certain pests. So, corn, for example, corn. Well, can you imagine what will happen if the corn will grow up eaten by the insects or pests? We will not have enough food for everybody in the world. But don't worry. Corn or bitty corn, the DNA of the bitty corn has been modified with the gene of Bacillus thuringiensis, a soil bacterium that produces proteins which is toxic to the corn borers or worm. So bitty corn is one of the success stories of genetically modified organism because before Miss Elasus volunteered for demos testing in her field, and the result is bitty corn yield is 7.2 tons per acre as compared to a rectangular yield of 4.2 tons per hectare. No insecticides spraying was needed. So bitty corn was successful. Next is virus resistance. Virus resistance is genetically modified plants to resist certain viruses. An example of this is GM papaya or rainbow papaya. The papaya ring spot viruses or PRSV is known to be detrimental to papaya plants. The protein of PRSV was introduced to the papaya plant through plant tissue, which turned out to be resistant to the viruses itself. The effect was like the vaccines humans have against measles or influenza virus. So PRSV or papaya ring spot is just for a papaya plant. If you can see, pag naman makita nyo ka ng papaya, then ang colored sa papaya kay yellow, green, then yellow, then green. Hinog na gani kay siya. Mga na siya gitawag og PRSV or papaya ring spot virus. Bisag, di ba ang true nga, ang kanang sakto nga hinog, dapat yellow siya. Yellow or orange. Hindi na line color. Yellow or orange. So, if makita nimo ang papaya na ay yellow, green, yellow, green, or orange, green, pero hinog na kaayo, mga na siya na ay virus. So, let's proceed. Next is Herbicide tolerance. Herbicide tolerance is genetically modified plants to tolerate herbicides. So, an example ani is Roundup Ready soybeans or glyphosate, an herbicide for weeds, was introduced to soybeans, making it tolerant to the herbicide itself. Farmers then can spray the herbicide killing the weeds but not the soybeans. So, as you can see, ang mga farmers kay ganing ilang sprayan ang ipananom nila. Kabantay mo ng mga saag na plants. Ang kana sila, napon na sila kanang mga kaugaling ng viruses. If masagol na siya sa mga plant nga kanang naay mga fruits, naay mga vegetables, well, ang virus nila or ang ilang mga gida nga kanang insects, pwede siya matakli. Which, pwede siya, ang next target sa weeds nga virus, kay ari sa kanang mga fruits or vegetable plants. So, manay kanang gilikayan sa mga farmers karon nga dapat gina siya masagdan ilang mga tanom o mga weeds para walay mga virus nga matakli sa ilang mga plants. So, next, fortification. Fortification is genetically modified plants fortified with a certain minerals. An example for this is golden rice. Golden rice is a beta-carotene, a precursor of vitamin A, was introduced through biosynthesis genes to the rice, making the rice grains fortified with vitamin A. So, beta-carotene. Carotene, ilan lang carrot. So, this beta-carotene rice, beta-carotene or golden rice, nagdani siya vitamin A. Vitamin A sa pagpalinaw sa mata. So, ang beta-carotene gikan sa carrots, butang sa rice. So that ang rice na siya vitamin nga gidala, which is pampalinaw ng mata. So next is cosmetic preservation. Cosmetic preservation is genetically modified plants to resist natural discoloration. So for example for this is Arctic apple. The apple variety was genetically modified to suppress the browning of apple due to superficial damage. So the use of this is para dili mag-brown ang apple. So next is increased growth rate. Increased growth rate is a genetically modified organism that has higher yield and growth than normal species. So an example of this is aqua advantage salmon. A gene from in an ocean pot, an eel-like fish was introduced to Pacific Chinook salmon, making the salmon grow faster than its normal rate. So as you can see in the picture here, ang upper part, mo na siya ang big salmon. So, mo na siya ang modified salmon, genetically modified salmon. Ang lower part, mo na siya ang normal growth rate sa isa ka salmon. So, nag-check kalahian if ang food or animal is mag-agi sa genetically modified process.
So, good evening everyone. I am John Lloyd Tangaro and my assigned topic is non-GMOs in non-food crops and microorganisms. Genetically modified organism or GMOs in non-food crops and some microorganisms involve the following. First is flour production, second is paper production, third is pharmaceutical production, fourth is bioremediation, fifth is enzyme and drug production, and lastly is GMOs in the medical field. So, the flour production, GMOs in flour production are seen in modified color and extended base life of flowers. Examples are blue roses, the so-called blue roses, which are in reality lilac or purple, contain cyanidin 3,5-diglycoside together with large amount of flavonols. The introduction of flavonoid 3151 hydroxylase gene in pelargoninin or cyanidin producing rose cultivars diverts the anthocyanin biosynthetic pathway toward the production of delphinidin glucosides and the flower color to blue by Eloma and Holton 1994. So second is paper production, modified characteristics of trees for higher yield of paper production. Examples are polar trees. Lignin is a complex polymer in trees that is removed from wood to make paper through crop process. Through inserting genes that code for ferulic acid in young poplar trees, the lining structure is modified, making lining easier to break down by Veneza 2014. Third is pharmaceutical production. Modified plants to produce pharmaceutical products. Examples are periwinkle plants. Bacterial genes were added to the periwinkle plant to enhance the production of vinblastine and alkaloid usually added to drugs for cancer treatments like Hodgkin's lymphoma by Rongopan 2010. Fourth is bioremediation, use of modified plants that can assist in the bioremediation of polluted sites. An example is shrub tobacco. Nicotiana glauca or shrub tobacco genetically modified with phytoskeleton TAPCSI1 is used for bioremediation. It shows high-level accumulation of zinc, lead, cadmium, nickel, and boron and produces high biomass. Fifth is enzyme and drug production, use of modified microorganisms that can produce enzymes for food processing and medicines. One example of this is CGTAs, cyclomaltodextrin glycosyltransferase CGTAs, an enzyme used for food flavor enhancer, is produced in higher quantity by Bacterium bacillus, which was genetically modified with a gene of thermophilic anaerobic. Thermonaerobic bacter carrying CGTAs by Pedersen and Jorgensen 1995. And lastly is GMOs in the medical field. Genetic engineering is playing a significant role from diagnosis to treatment of human-related diseases. It helps in the production of drugs, gene therapy, and laboratory researches. One classic example is Humulin, the genetically engineered insulin used by type 1 diabetes patients who are insulin dependent. In the past, insulin is extracted from the pancreas of pigs and cows that have caused allergic reaction to some diabetics using it. In 1978, researchers from the City of Hope National Medical Center and Genentech Biotechnology Company were able to produce human insulin. The gene for insulin was inserted to bacterial DNA that was able to produce almost exactly the same human insulin. This was breakthrough in the mass production of human insulin. In 1996, modified human insulin was approved called the Humalog. And that's all. Thank you.
Good day everyone, my name is Zaira de la Vega and I am tasked to discuss about the benefits of the GMO. So GMOs and their function in the food and agricultural industries as well as non-food crops and microorganisms have been discussed previously. And right now, I'll be highlighting its benefits. So studies show some of the potential benefits of GMO and these are higher efficiency in farming, increase in harvest, control in fertility, increase in food processing, improvement of desirable characteristics, nutritional and pharmaceutical enhancement, and lastly, they reduce the use of fertilizer and pesticides. So for higher efficiency in farming, with the use of pesticide-resistant or herbicide-tolerant GMO crops, there will be less use for herbicides or pesticides, and it will also lower costs for labor and cultivation. Farmers will likely spend less money on pesticides if they use GMO, and they will be able to control weeds more easily. So next is the increase in harvest. GMO crops resistant to pests and diseases means increase in potential growth and harvest. Greater resistance to viruses and other illnesses is a good thing because it will result in higher yields and a more appealing product. And also, it will result in less waste and increase of food security. For control in fertility. Controlling the purity of the hybrid seeds or the GMO seeds ensures higher yields. So farmers will find it easier to regulate the purity of weeds in farming, as I have previously stated, because of the herbicide tolerance. And the next one is increase in food processing. Altered characteristics of GMO crops help ease food processing. So, following is the improvement of desirable characteristics. GMOs offer longer shelf life, enhanced color and taste, enhanced production or reduction of enzymes, and other modified characteristics of plants, animals, and microorganisms. So, another advantage or benefit of GMO is that it extends shelf life, resulting in reduced waste. Also, it improves color and flavor and boosts consumer appeal, such as apples and potatoes that are less likely to bruise or turn brown. For nutritional and pharmaceutical enhancement, GMO crops like maize fortified with lysine and golden rice fortified with vitamin A and iron, which can boost the health of people with limited access to food. Also, there are now edible vaccines for viral and diarrheal diseases. Lastly, further reduce the use of fertilizer and pesticides. I assume this still falls on the farmers. It will benefit them greatly in terms of spending money on pesticides and herbicides for their crops.
And my topic is potential risk of GMO. So, despite the promising claims of GMO, the opponent of GMO claims otherwise. For example, there are studies that show a link in the adaptation of pesticide-resistant GMO crops to the significant growth of superweeds that become pesticide-resistant. To this cause additional problem to more than 12 million acres of farm in the United States. Opponents of GMO have the following major concerns. First, since genetic engineering is still young, branch of science there have indicate studies on the effect of GMO, human and environment. Second, genetic engineering promotes mutation organs which the long-term effect in scale unknown. Third, a no consumption of GMO might have the following effect: more allergic reaction. GMO foods may trigger more allergies reaction, more so create new ones as a one side effect. Second, gene mutation, develop abnormalities and mutation. Antibiotic resistant, nutritional value, food may have changed in their moral value. Potential environment risk caused by GMO. Risk in gene flow, emergency form of resistance, and secondary is the weed problem. Recommendation of virus and bacteria to produce the pathogens. Okay.
Hi everyone, I'm Jamaica Bohols and I'm going to share my topic of potential health risks caused by GMOs. A major concern in the use and consumption of GMOs is its effect on human beings, primarily on human health. Some potential human health risks are identified, such as the consumption of GMOs may have adverse effect since it is not naturally or organically produced. Consumption of GMOs may alter the balance of existing microorganisms in the human digestive system. Production of toxins may be detrimental to human health, and production of allergens may have adverse effects on humans. Worldwide, there are many groups that campaign against GMO food consumption. They encourage people to boycott GMO products and to be vigilant in checking if the food they buy has GMO ingredients. In the Philippines, the Supreme Court has ruled against the use of eggplant, another genetically modified crop. Other potential health risks that raise major concern are Human Genome Project, or HGP. Mapping of human genes to provide framework to research and studies in the field of medicine. was feared that the ability to produce human genetic information would create biases and give much power to people holding the information and to the disadvantage of those who do not have the genetic information. Second, mutation of genetically engineered microorganisms. Genetically modified bacteria and viruses may mutate to become more resistant or virulent that may cause more dreadful disease for human beings. Third, cloning. The sexual reproduction of an organism using parent cell through genetic engineering. In February 24, 1997, the first mammal, Dolly, a sheep from Scotland, was born through cloning. With its celebrated success came that fear of human cloning. It's emerged that ethical issue of man playing God. On the other hand, great fears loom in the process of this quest. There are many things to be considered before a certain medical process using genetic engineering be accepted. These concerns were affirmed by the reports of the World Health Organization, or WHO, reported 3 major issues on GMOs that are in international public debates. These are the potential risks of allergic reactions, gene transfer flow, and outcrossing. The primary issue on GMOs presented in public debate is its unnatural production, or what is termed to be violation of nature. The creation of new organisms like GMOs posed more issues on defiance to natural laws. Another concern is the potential risk to the environment and human health, to which so much is unknown yet. That's all.
Good day everyone, this is Ramel Barchana and I will share to you my topic about biosafety on GMOs. There are initiatives for the protection of the general human population regarding the issues and concern about GMOs. So, daghan man og potential risk ang GMO, daghan kay issue. So, kani nga akong topic mo ni ang nagpamatuod nga safety ang GMO. The Food and Agricultural Organization, or the FAO, together with the World Health Organization, WHO, created the Codex Alimentarius Commission, in short, Codex. Codex is an intergovernmental body that develops the Codex Alimentarius, known as the International Food Code. Codex is responsible for the development of standards, codes of practices, guidelines, and recommendation on food safety. With the pressing issue and concern on GMOs, in 2013, Codex has developed principles for the human health risk analysis of genetically modified food products. The principles include pre-market assessments of GM food products and its evaluation of direct and indirect effects. However, the Codex principle has no binding effects on national legislation but through the sanitary of phytosanitary measures of the World Trade Organization, national legislators are encouraged to complement their national standards with the Codex principles. Cartagena Protocol on Biosafety. The Cartagena Protocol on Biosafety, established in 2003. Cartagena Protocol is an international environmental treaty that regulates the transboundary movements of living modified organisms, or LMOs. The Cartagena Protocol requires exporters to seek consent from the importers before its first shipments of LMOs. International Trade Agreement on Labeling of GM Food and Food Products. The agreement requires exporters of GM food and food products to label their products and give rights to importing parties to reject or accept the GM products. The premise of this policy is that consumers have the right to know and the freedom to choose GM or non-GM products. The World Health Organization claims that all GM products that are available in the national market have passed safety assessment by national authorities. The safety assessment basically look at the environmental and health risk factors, and food safety actually follows the Codex Food Code. So, ang World Health Organization, may claim sila tanan kunong GM products na available sa international market have passed safety assessment by national authorities. Ito guys, thank you.
Next is GMOs in the Philippines. There is a National Committee on Biosafety of the Philippines, or NCBP. Executive Order number 430 of 1990. The NCBP developed the guidelines on the release of genetically manipulated organisms, or GMOs, and potentially harmful exotic species in 1998. This executive order was signed by the President Gloria Macapagal Arroyo. It is concerned about the health care of people in the Philippines, agriculture and chemical equipment, which where biotechnology has a potential to improve the quality of human life, and it may risk on hazard to health safety of the people. Then next is the Department of Agriculture released Administrative Order number 8 when genetically modified organisms, or GMOs, were allowed in 2002. The Philippines was marked to be the first country in Asia to approve commercial production of GMOs. There are 70 GMOs applications approved by the Department of Agriculture for the release to the environment. 62 GMOs of which are approved for food, feed, and processing, and the remaining 8 were approved for propagation. And then in 2006, Philippines became part of the Cartagena Protocol of Biosafety. Executive number 514 was issued to address the biosafety requirements of the Cartagena Protocol and the establishment of the National Biosafety Framework, or NBF. So here in the Executive 514, its purpose is to rapid the expansion of the used modern biotechnology, not only for research but also for products commercially. In Executive 514, it promotes safety and responsible use of modern biotechnology products by means of achieving sustainable and safe environment. Then the next is the Organic Agriculture Act. The Organic Agriculture Act was issued in 2010, encouraging organic agriculture than GMO-related agriculture. So in this act, government encourage farmers to produce organic products than GMOs products, or those products that are chemically processed. Next are some places in the Philippines that produces organic products. Include the following: several provinces like Negros Occidental and Negros Oriental, which agreed to support organic agriculture. There was the establishment of the Negros Organic Island through a Memorandum of Agreement, or MOA, between the two provinces in 2005. These two provinces were able to ban the entry of GMOs production through provincial ordinance. Next place is the Davao City, who passed the Organic Agriculture Ordinance in 2010. This city ordinance helped the prevention of field testing of GM BT eggplant in the UP Mindanao campus. This place also promote organic products and leaving the GMOs production through city ordinances. While in 2012, Representative T.D. Casino, together with the congressman, filed a bill pushing for the mandatory labeling of GM food and food products. This is for us netizen to be aware of which product or food that are being processed and not. They're doing this to ensure the safety of people here in the Philippines. In December 2015, the Supreme Court ordered to put an end to the field testing of GMOs DT eggplant and declared Administrative Order Number 8 Series of 2002 of the Department of Agriculture related to GMOs importations propagation is temporarily put to stop until a new administrative order is issued in accordance with the law. So next is the 5 government agencies. In March 7, 2016, government passed a joint department circular number 1 series of 2016 on rules of regulation for the research and development. So number 1 is the DOST or the Department of Science and Technology. Number 2 is the Department of Agriculture. Number 3 is the Department of Environment and Natural Resources. Number 4 is the Department of Health, and lastly number is 5, the Department of Interior and Local Government. So these 5 agencies, they help farmers find a better way to produce organic and inorganic products, considering the positive and negative effect of it to the development, environment, and to the people. Thank you very much.
Good day everyone. I am Marjon Dilaw and today I will discuss all about the relevant global challenges or issues or problems about GMO and what is the solution to this issue. First is, what is GMO? GMO or genetically modified organism is a plant, animal, microorganism or other organism whose genetic makeup has been modified in a laboratory using genetic engineering or transgenic technology. Next is, what is the relevant global challenges or issues or problems about GMO? Here is the most relevant global challenges about GMO. Here is lack of research. Lack of research is one of the biggest problems with genetically modified foods. In the lack of independent research on the subject, if GM foods were confirmed as being detrimental to consumer, this would be further outlawed all over the world. They are already banned in several countries. Here are some challenges of horticultural GM crops production. First is environmental pollution. Next is unintentional gene transfer to wild plants. Then possible creation of invasive weeds. Then risk to crop genetic. And then last is part of unknown effects. And there are some solutions to avoid these issues. First is, you need to buy foods labeled with 100% organic. Low prohibits genetically engineered food or ingredients in product labeled 100% organic. Second is, look for non-GMO project verified label on product packaging. And lastly is, eat locally grown food. And that's all for today. Thank you.